All right, I'm Justin Coyne. For those who don't know me, I come from Stanford University Libraries, where I've been for a couple of years. Mostly, I guess, a repository developer, and I've been really actively involved in the Samvera community. But over the last 6 months to a year, I personally have really disengaged with actually working on Hyrax and stuff. And so when I was coming to this conference, I was like, well, what can I bring to this conference that I have been working on? And what we have been doing is a lot of DevOps stuff, a lot of deployment, and a lot of working with AWS. And I thought it would be great to share that with people because I think it's really neat. And I kind of think it's the future of how we should be deploying things. And I think it gives us a lot of great advantages. So I'm going to start with an abbreviated history of cloud computing. In the beginning, we had the server room. How many people here are running real servers on real racks? Okay, it looks like 60, 70%. I used to do this when I worked at the University of Minnesota. Like we'd go to the loading dock and unpack boxes and stick them in, screw them in, wire them up. It was a lot of fun because it wasn't like doing the same thing I usually did. But at the same time, I wasn't really focusing on what they hired me to do. So things changed for a lot of us around 2006 when Jeff Bezos of Amazon offered their cloud environment to the world, and they offered to rent you a VM, and they called that EC2. So basically, this gave us a way to, I guess, not worry about all that metal and just worry about, we have a machine and we're going to put software on it, and that'll be great. So we no longer have the need to deal with hardware or manage a server room, and we can really focus on our core library, archive, repository competencies, which is delivering repositories, working on preservation, access, discovery. Our core competency is not really in managing these machines. Those are just something we have to do in order to deliver the services we want to give to people. So cloud allows us to outsource those things we need to do but aren't part of our focus. We don't want to negotiate with hardware vendors, arrange payments, find the rack space, install them, hook up the networking, find cooling, find power, and manage the life cycle of that because you have to repeat it every 5 years or so. So unless you have a legal requirement to have your own hardware, or you have some funny accounting where you're not actually paying for the hardware you're using, I absolutely recommend you use cloud resources. So 10 years ago, there's this Linux container project got started. A container is a set of processes that are isolated from the rest of the system. They allow us to manage a single service apart from the operating system itself. And right now, Docker is the de facto container standard, but there are others out there if you're really interested in looking at that. So more recently, these providers have come up with containers as a service. This has probably happened for about 3 years now. All the cloud providers have something in this space. So there's Azure Container Service from Microsoft, Elastic Container Service from Amazon, there's Droplets from DigitalOcean, and there's the Google Kubernetes service from Google, and there's many, many other providers out there that are offering all these same things. And what they're offering here is hosting for your containers, your Docker containers, and an orchestration service. And an orchestration service organizes those individual containers so that they can make up an application. So they have network access, they can talk to one another. And it allows us to roll out new versions of software without disrupting the users. It allows us to scale these containers to meet the needs we have. So why would I want to do containers? First of all, we get a consistent environment out of this. You get a great deal of power or give a great deal of power and responsibility to the developers, because they're going to be the ones who are making these Docker images. This is really different from how we deploy our Rails projects on a VM, where you're going to like shell into the VM and run a bunch of scripts. We typically use Capistrano for that. And what can happen is you're testing it on one environment, you're developing it on a different environment, and you're deploying to a totally different environment. And things can change there. You're not doing a great job of managing what you've deployed. And with Docker containers, that's different, because you can build it on your desktop and run it on your desktop, move it to a testing machine, move it to production, and the only thing we need to change is configuration, which is typically going to happen through environment variables. So it's a much smaller set of things we need to manage when we move environments. So the idea here is we're going to end up with fewer like, well, it works for me on my laptop, but and fewer calls from like your ops people being, well, why doesn't it deploy? So isolation is another benefit. So on a virtual machine, the application could be dependent on the host operating system. And with containers, we're making all our dependencies very clear. There's no like accidental things we depend on. We're going to list everything out in our Docker file. And this makes it possible to prevent problems like when a database uses up all the memory and then the kernel says, well, we're out of memory, something needs to die, it's going to be the web server. That sort of thing isn't going to happen, because we're going to provision each container, each with its own resources, and it can't really leave its box. So we can run these containers anywhere. That's nice, because we could provision them all on one box if we can. But when we start growing our service and we find that we need more database resources, we can take half of our containers and move them over to another server. Or if we find we need more containers of the same service operating, more instances, we can just spin up another instance. Super easy. And it doesn't really matter where they're running. They can run anywhere. That's not important to the application level. Finally, I'm going to argue that the deployment story is the best deployment story you possibly could have. You're going to build it on your desktop. You're going to move it to production. The only thing that changes is the environment variables, where you say the database URL is over here. The password for the database is whatever. So I hope you can see why containers are bringing a number of benefits and seems to me to be the future of like cloud computing. So at Stanford, we've been using Elastic Container Service, or ECS, for just over a year now, and we're pretty happy with this decision. I'm going to walk through what it takes to spin something like this up. So if you have an account on Amazon and you've given them your credit card at least, you can go to the ECS tab and say, create a new cluster. And when you do that, you're going to be presented with this choice. It looks like a choice amongst 3 things, but really the first choice is amongst 2. And the choice is, do I want to use Fargate or do I want to use EC2? If we're running on EC2, what that means is we are going to provision EC2 server or VM instances, and then we're going to place the container host stuff on top of that, and we have to manage those EC2 instances, like patching and stuff like that, and provisioning them. And that is, it allows you to be more flexible, but we really don't care about that stuff. That's the kind of stuff at Stanford we would rather have Amazon take care of for us. So this Fargate came out about a year ago, and that allows us to just talk about the actual container instances, not the servers at all. We don't have to care about the servers anymore. We just care about, is this container running somewhere? So we're going to go and select that Fargate option. And when you do that, it's going to give you one screen of things we need to specify. First thing is a cluster name. We're going to put demo cluster up there. And it's going to ask you a little bit about networking. So the first option is create a VPC, and that means like a virtual private cloud. Typically, we'd only have like one of these per environment. So we might say, this VPC represents the development environment or the staging environment. It is challenging to get things in different VPCs to talk to each other. So if you have services that need to talk to each other, it's best to keep it all in one VPC. It's also nice to segregate your development and your production environments, because then you can take that whole VPC down if you want to. Delete the whole thing. In this example, I'm just saying create a VPC, but this is if you already had a VPC created, you would uncheck that and specify the VPC. When you hit create, it goes to this process. It kicks off a bunch of commands in the background. So if we were doing this via the command line option, we'd have to issue about like 15 commands. And this page is going to take about 5 minutes for it to complete. And it slowly goes, oh, this is done, this is done, this is done. But it's pretty cool that all I have to do is that one click and boom, we have a cluster. It did all this stuff for us. It was kind of magic. So the primitive unit in ECS is the task. And a task is like a set of containers and how much memory they get and how much compute units they get. So we're going to configure a new task. Oh, and a task could also be something that is a server, like a Rails server, or it could be something that just runs and terminates. Like, could be an FFmpeg where you transcode a video from one thing to another, and then it's done and it quits. So a task is just a container. It doesn't care if it's a server or a batch job. So you just enter a task definition name up at the top. We're going to pretend we typed in Samvera demo, because we'll see that later. You have a couple optional things to set, but the most important thing is when we scroll down here, that we set the task size. If you can't read here, it says the task memory and the task CPU. And that's how they're going to bill you, right? If you set a big number, the bill is going to be very big. If you set a small number, the bill will be small. And then the important thing to touch here is this button, the blue button that says Add Container. And that's going to take us to a next page where we are going to say, hey, these are the containers we want to run when we say run this task. So I typed at the top, the container name is hello world. And in the next box, I have to tell it where to get the image for this container. It will look at Docker Hub, or Amazon has a private image hosting service you can use. I'm just selecting an image out of Docker Hub, and it's called Faraday/Rails_hello. And that's like the hello world of a Rails application. I took like 20 seconds to Google for something like that and found that one and pulled it down. All I had to do was type that in there. The other important part of this page is right here, the port mappings. I set port 3000 because Rails development server by default is running on port 3000. So I need to make sure I open that up. And when I click to the next page, it's another one of these few minutes of waiting. And it said, hey, I got that task created for you. And since a Rails application is a server, we need to set up an ECS service. And the service is where we're going to define our networking and the scaling and that sort of thing. We're going to do the simplest possible thing. So all we're going to do is say, hey, I want you to run that Samvera task that we defined a couple pages back. And I want to run it on the demo cluster we did even at the beginning. And we'll give the service a name. We're going to call it Samvera service. And here it says, how many tasks do you want to run? And I'm just going to say one. That's all we've changed on the page. I'm just going to do next page. So the next thing it says, what VPC, what virtual private cloud are we running it in? And I'm picking the one that was automatically created when I checked the box. I have to set the subnets it's going to run on so it can network to the other things. I set a security group. That, again, was auto-created for me on that first page. And I'm saying, yes, assign it a public IP. That's important when you make a server if you want it to talk to the outside world. Down at the bottom, it's asking, like, what kind of load balancing and health checks do you want? And since we're just doing a single instance, we're going to skip over that and say no load balancer. We're going to go right to that node. On the next page, it's going to say, how about auto-scaling? Do you want to set up auto-scaling? And auto-scaling, what it will do is you can set up some metrics, some alerts that happen when there's a threshold crossed. Like you may set the threshold to be when the server is using more than 70% of its CPU, do an alert. And then you can bind the auto-scaling to that alert and say scale up when this alert is encountered. And we can set up another alert that says CPU is less than 30%. We can say scale down when this alert is encountered. And we can set a limit here, like only scale up to 5, because I mean, I don't want to break the budget, right? The one thing to remember here is you don't ever scale down to less than 1 in here. And so you're always going to be paying for this one server running all the time, which is kind of unfortunate. And if you really don't want to do that, Amazon offers another solution called Lambda, where it's only going to pay that cost when it's invoked. Lambda has a whole bunch of other restrictions. It's not a container kind of thing. So we're just going to, I guess that's an exercise for all of you to investigate. All right, the last page is just a review. It's like, is this all right? And you say, yep, that's right. And again, another one of these pages where you wait a little bit and it runs a bunch of commands in the background that you don't see. And then right now I've jumped over to another product that Amazon offers called CloudWatch. CloudWatch it does a number of things, but one of them is it aggregates all the logging together. I love CloudWatch because you can see across all these images you're running. You can run a search for the logs, and you can narrow it down by what date range and everything. And this is automatically set up when you run through this script. And if you can read these logs here, it's basically the Rails startup stuff. It says, it's listening on port TCP port 3000. So basically, what we know so far is the task is running, right? If you try to go to the IP address it had, unfortunately, it's not going to let us in because it's on port 3000. So there's one more thing we have to do. And that's modify the security group. So the security group is similar to something like IP tables if you're running VMs. And what we're going to do is add a custom rule here that says allow ingress on port 3000 to everybody in the world. And it's port 3000 because that's the port our Rails server's running on. And we just hit save. And as soon as we do that, we can access the machine at its public IP on port 3000 and see that, hey, we're on Rails. So at Stanford, we prefer not to click through all this stuff I just showed you. I showed you this to show how easy it possibly could be to get set up. The problem is, say you found that you did something wrong or you want to make a change. You go back in there and you click a change, and then all of a sudden it stops working. It might be hard to remember, like, how do I revert that change, or what change did I even make, right? We like to manage all our configuration that way. So we use a scripting program, or a scripting language called Terraform, and that allows us to put all our changes into a Git repository, and we can audit, like, who made this change? When did they make it? Hopefully they said why they made it. We can revert changes. And it also allows us to delete everything and just rerun it all again from scratch. I was a little bit intimidated by Terraform my first time, but it actually is really amazing. When you run it, it can go through and scan all your infrastructure and compare it to the instructions that you've given and say, it looks like these 3 changes are needed. And if you have changed it, on the console, it'll say, hey, it looks like you made changes over here, but they're not in the repo yet. So you can go ahead and either port those in the repo or acknowledge that, like, yeah, I don't want those. I'm going to wipe them out. There's a few other steps we probably would have used if we're putting this into production. Like, we'd want to set up a load balancer probably with more than one node. We'd want to set up a DNS record, and we'd want to forward the ports to like port 80. But that's really orthogonal to using containers. All that tool is available. It's just, more steps to go through. But today, it's all about containers. So some of the terms I talked about are really important. And unfortunately, they're kind of used in different ways. The cluster is the thing we set up first, where this is just a pool of tasks, and it's going to run it on machines. It doesn't make so much sense in Fargate as it does in EC2, the EC2 version. In the EC2 version, you're going to put instances in your cluster, and in Fargate, you don't. So the cluster really, in Fargate, is a name and which VPC is it running in. Now, the task is the primary primitive of ECS, and that's which container should I run and how many resources do I allocate to them. And that's the thing that's going to govern how much our bill is. And then finally, there's the service. And that's if we are going to run our task as a web service, we need to set it up there. That means we're going to set up our networking and our load balancing and our auto scaling. So I'm sure everyone's wondering, like, hey, how much is this going to cost me? So the cool thing is they bill you at a per second rate, minimum 1 minute. And the cost per second is very, very low. It's a fraction of a cent. But it works out to about $36 per month, which is great until you're like, oh, but memory's separate. So there's another $9 a month. And that's going to work out to a little less than $600 a year. If you add another gig of memory, if you have 2 gigs of memory, that's going to be a little bit more than 600, maybe 650 a year. But the cool thing is you're not having to pay that cost all the time. You can turn it off when you're done. You can turn it off on the weekends. You can turn it off when it's summer break. Whenever you're not using it, your development environment, when you go home at night. And you can easily set up auto scaling to add capacity when you need it, and then scale it down to the baseline when you're not using it. And that's really powerful because if you're running on bare metal or even on EC2, you're basically provisioning for your highest loads. And quite often you're underutilizing that until you're at the peak and you can't do anything. So here we're able to say, scale up a reasonable amount, 10 servers, whatever's in my budget. And then so I'm most of the time only paying that baseline rate. Sometimes I'll pay when I really need it. So Hyrax isn't amazing for putting into cloud stuff right away. It was obviously built for a world of VMs and shared file systems. And those things don't scale well, and they're expensive to do in cloud world. So Hyrax, by default, looks like this. A number of years ago, I was working with Penn State, and they had a Hyrax web app, and we had some asynchronous workers, and they were all on one box. And at that point, everything was kind of slowing down. They were hitting capacity limits. They were like, we're going to put it on a different box. How are we going to do that? And we worked together and decided that I think if we just put a shared file system underneath all the boxes, everything will write to the same place, and it will be gravy. Unfortunately, that's not a great solution to give back to the community because it takes a certain amount of know-how as a sysadmin to manage an NFS stuff if you don't already have that. It's not easy for everyone to do it the same way. And it's really not scalable. And if we try to do this in the cloud, it gets expensive because we have to mount a block store. The other problem here is as this scales to, say, 100, you're going to have contention for that one disk. So Haiku ran into this problem about 2 years ago, and we switched the back end to using S3, and that's something that other places like Northwestern are also doing. It didn't require a lot of changes, just a few tweaks to Hyrax, but I can't help but think that it would be better if the community could centralize around something like active storage and have a model that looks like this by default and allows you to configure the old way of using NFS if you need it. So how can we make Hyrax make better use of containers? So I see Valkyrie as playing a really important role here. I think we need to mediate between our services and the application layer. So I'd love to see that get into Hyrax. I know we're going to need a bunch of help doing that and a bunch of people involved. I'd really like to explore Elasticsearch rather than Solr. Elasticsearch is a product that Amazon offers out of the box. It's pretty easy, but it's quite different from Solr. We'd have to change Blacklight a bit, and there's been some work to go there, but it's not done yet. And Solr is a little bit harder. You basically are going to have to spin up either containers to put that in, or you have to run it in Elastic Beanstalk. And it's just not as easy as using a fully hosted solution. And then I think we need to increase our investment in Haiku or some other like ready-to-go Hyrax, especially for people getting started. Because I think running the Rails generate Hyrax is not necessary for everybody. And it allows us to do things like ship it with Docker files like Haiku has. And right now, I think Haiku has sort of been marketed a little bit wrong as if it's only for service providers. And I understand because I'm probably part of the reason that got marketed that way. But I think we could do something similar that's targeted more at the new adopters and places that don't have a ton of development resources to truly have like an out-of-the-box Samvera project. And that's what the whole Hydra in a Box grant was about. And we found that containers was a really good way of getting everybody there. So do I have 2 minutes or done? 3 minutes? Are there any questions? Oh, yeah.
My question.
Do you want to use them?
My question was on the vCPU that the containers use. Can you have more than one Rails app share the same vCPU? Or is that like one Rails app per vCPU?
You could, but I think it probably wouldn't be like the best practice. I think you'd want each Rails app to be in a separate container. And yeah, they wouldn't necessarily share the same vCPU. Okay. You could also, yeah, there's a bunch of ways of doing it. You could put two Rails apps in, merged together somehow with Rack, but I don't know. I suppose the best way is to spend more money.
Okay.
Yep. Can you pass this?
Is there a reason why you chose to use Terraform as opposed to continuing to use CloudFormation in AWS? That's my first question. And the second is, how do costs compare for Fargate versus using EC2 for ECS?
I'm actually not the best person to answer either of those questions, but Aaron, would you mind taking the first one?
So the Terraform decision was largely made by our ops team. They just were having trouble with sort of the reliability in the way we were doing things with CloudFormation. So they wanted Terraform. Terraform is also a little more sort of infrastructure as code workable within dev practices. So we can follow our normal day-to-day dev practices with Terraform a little easier. That was one decision for that. And then the second part of your question around cost, I think the cost is about the same with Fargate. The big distinction between Fargate and like classic EC2 is that they don't actually show you any of the resources it's using. So in the classic version, it had like an instance and things you could shell into. You don't get that anymore. You just have a container it does its thing. You can't connect to it. There are ways, but not easily.
And our biggest concern is it just takes stuff off our plate that that don't give value to our users. So.
Can I just add on to that real quick? And this may be obvious, but I think another benefit of Terraform is it gives us looser coupling to Amazon. I believe CloudFormation is Amazon only. Terraform allows us to switch providers if at some point, Google's offering or Apple's offering or whoever's offering is going to work better for us. Or we can ship it locally using Terraform. There were other hands.
All right, I think we're out of time, though.
Oh.
Thank you.